Hey there, welcome to a video for section 5.2. This is a topic on graphs of polynomial functions. So first off, what is a polynomial function? So if we see the definition there, it's a function in terms of non-negative integer exponents. So a lot of terms there, but sorry, a lot of words. So first of all, let's focus on non-negative. So it means that you'd have 0 or 1 or 2 or 3 or so forth, because they're also integers. So your exponents are going to have those numbers. So for example, if I have a x to the n plus b x to the n minus 1 plus dot 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 k, one example could be like 2x to the 4 power plus 5x cubed minus x plus 10, let's say. So notice how all my exponents are integers and are not negative. Of course, if you have plain old x, you assume the exponent's 1. And if you have just a number like 10, we call that a constant. You could put an x next to it. The next one would be 0, because anything to the 0 power is 1, as was discussed in section 5.1 the previous day. So anytime you have an expression that has a whole bunch of x's in which the exponents are non-negative integers, that's going to be a polynomial function. Sometimes it can be in factor form. That's a possibility too. They could look kind of like this, like x plus 1, x minus 4, x plus 5, and so forth. So that would also be a polynomial function, because if I were to FOIL it, you would get x to the third plus dot dot dot, a bunch of other stuff as well. Another term we need to discuss, the degree of a function, of a polynomial function. It's the highest exponent. We also call it the leading term. So it's usually what we start with when we write these functions. Turning points are lows and highs. So, and usually the turning points will be the degree minus 1 or n minus 1. That's actually the max number of turning points, just so you know. So sometimes you may not have that many turning points. So for example, if I have a degree 3 function, it could look like this. If you have degree 3, it could have 2 turning points, as you see there. But it may not necessarily have 2 turning points. It could also just have no turning points, like that as well. So that's just something to kind of let you be aware of, and you'll start making more sense of it as we get deeper into this unit. Leading coefficient is just the first coefficient you see next to the highest exponent. So in this case here, 2 would be my leading degree for what I wrote just about a minute ago. Sorry, that would be my leading coefficient. And the constant term is any term without a variable, and we just call it k, or like in this case here, 10 was my constant term. It's also going to be the y-intercept, so you know. If you were to plug in 0 for x, basically all these would just go away, and you'd be stuck with the constant. So it also represents the y-intercept. Now, to graph these in your calculator, just hit the y equals button. You should see in the top left corner, as we should know. And then you start, typing in, the actual equation. Remember, x is going to be located right below mode, and then the exponent button you should see right below clear, and you could just sort of just start typing away. You may need to adjust the window if needed, and you could just hit the button window, which is next to y equals. And you could change the minimum and maximum x values that the window will show, as well as minimum and maximum y values. So totally up to what you're graphing. I mean, usually what I do is I punch in the equation and graph it. If it looks kind of weird, if I can't see much, then I'll just go to window and just change it up a little bit, depending on what I'm seeing. If you hit second, then the trace button. So second, then trace. which actually is going to be the calc feature, you actually could have the calculator compute a few things for you. You could actually have it do the x-intercepts, which is just the zeros. That's option 2, or option 3 or option 4 are the lower high points. Usually, what you'll need to do is you'll need to pick a left bound, a right bound, and then a guess. So usually you're going to have to type in 3 different things. But like the way this would work is if I had something kind of like this here, right? And I want to find that low point. Obviously, that's going to be option 3 because that's a minimum. But when it's asking for a left bound, I'm going to just pick some random point to the left of where I feel the minimum is. Then I'll pick something to the right where I feel it is. And then guess, just hit enter. And what it'll do is will find the low point for you. Likewise, for maximum, just repeat the process or x-intercepts. So that's exactly what's happening down here. Left bound, right bound, guess. So you could actually try this as an example in your calculator and figure out what you get. Of course, you can do this on Desmos too. But and I don't have a TI-84 software on my computer here, so you'll just have to kind of just do this and see what happens. So x3 plus x squared minus 5x plus 1. Just make sure you type this in correctly. So I'm punching in right now. Hit graph. And you actually see it pretty nicely. It actually looks something kind of like this. So if I want to find my x-intercepts, I first have to go second trace, 0. And I'm going to have to select a point to the left and a point to the right. So when it says left bound, like for example, right now I have x equals negative 2 point something, and y is negative 2 point something, I'll hit enter, store it, and you should see a little like arrow kind of appear. And then I'm going to move the cursor to the right, as you see right there, hit enter, like maybe if I have like negative 1.4 or negative 1 point something, you'll see another arrow show up. Then just hit enter one more time, and it's going to give you the x-intercepts. So one of the x-intercepts is going to be negative 1.903. And I just repeat it. If you are stuck with this, circle this and then ask your teacher the next day or ask a classmate. The next one should be 0.194, and then repeat it. To the left, to the right. I should get 2.709. And then we do see 2 turning points. Remember, the number of turning points is going to be 1 less than a degree. That's the maximum number of turning points you could have. So I clearly have a maximum. So it's kind of like that little hill right here. It's my maximum. The little bottoming out point, if that makes any sense, or trough is going to be your minimum. So if I find my max, I'm going to go a little bit to the left, a little bit to the right of the hill, and I should get negative 1,4. So that's a very nice number. And for my low point, I'm going to do that minimum, go a little bit to the left, a little bit to the right. Should get 1.6667, negative 5.481. Desmos will get you the same thing too more easily. Obviously, it's better to use Desmos, but on standardized tests, especially for the AP Calculus curriculum, if you wind up taking that course, you're going to have to do this in the calculator. So it's just a skill that's going to take some time to develop. And definitely ask your teacher for help. And of course, when I'm back from my leave, I'll definitely be happy to show you again, because we're going to be doing this often in the semester using the calculator. Now, you are going to know some patterns when you're graphing these functions. So in general terms, if we focus on the leading term, we have a bunch of other junk. Remember, n is our degree. I'll call a the leading coefficient. If I just focus on the term with the highest exponent, I'll know some patterns. For example, if I have an even degree, like say y equals x squared, and my coefficient is positive, I know it's a parabola that kind of looks like this. So on the left side, my arrow is pointing up. On the right side, the arrow is also pointing up. What if I have an even degree with a negative leading coefficient, like y equals negative x squared? I know it's going to look like this. So in this case, both arrows are pointing down. What if I have an odd degree with a positive coefficient? Let's say I did y equals x cubed. If you're graphing the calculator, it's going to look kind of like this. So on the left side, the arrow points down, the right side, the arrow points up. And if I have an odd degree, a negative coefficient, like y equals negative x cubed, it's going downhill. So left side arrow up, right side arrow down. Now, we are going to write this in something called limit notation. And here's how it's going to look. You're going to write it like this. As x approaches negative infinity, y approaches positive infinity. So let's think about that part. On the left side of this curve, obviously if I'm going to the left, x is getting more negative, so we say x is approaching negative infinity. Y is pointing up, so we say y is approaching positive infinity. On the right side, clearly x is getting bigger, so we would say as x approaches positive infinity, y is also approaching positive infinity. So that's how you write limit notation. It's something you really want to get accustomed to because you're going to see it a lot in pre-calculus, and calculus, it's what you do all the time. So we'll keep moving. So every single time when you do limit notation, you're always going to say as x approaches negative infinity, as x approaches positive infinity. You're always kind of curious to know what's happening to x as x gets more negative, as x gets more positive. So we're going to kind of just repeat that for the other three scenarios here. And then the question is, what is y doing as x is doing these things? So how does y respond to that? With x being kind of like what we're controlling independently. So if you have an even degree with a negative coefficient like we had here, clearly the arrow is pointing down in each case. So we're going to say y is approaching negative infinity in each case. Y is getting more negative as x gets more negative or as x gets more positive. That kind of makes sense numerically because if you're squaring something as positive, then if you multiply by negative afterwards, it's negative. X cubed, now if you're cubing something positive, it stays positive. If you're cubing something negative, it's negative. So as x approaches negative infinity, y is also approaching negative infinity. As x approaching positive infinity, y is also approaching positive infinity. And it's just reversed if you have with an odd degree with a negative coefficient. So as x gets more negative, y actually gets more positive. Think about it. You're cubing something that's negative, but then you multiply by negative, and negative times negative is a positive. Where it's vice versa over here. If x gets more positive, fine, you're cubing a positive number as positive, but you multiply a negative, that becomes negative. So that's called limit notation. We're going to actually try this on a few problems here, so you kind of get the hang of it, and you'll do some practice on your own. Actually, the practice will be in class as part of the classwork. So, without actually graphing, my degree here is 4, my leading coefficient is 3, here degree is 3, leading coefficient is 4, here degree is 3, leading coefficient negative 1, here degree leading coefficient, degree leading coefficient, degree is 6, leading coefficient of negative 1, degree 5, leading coefficient of 1. So really quickly, I kind of like to draw the arrows. If you have an even degree, they go in the same direction and positive coefficient both point up. Here's going to be down up because you have an odd degree. So you can think of odd like they're at odds with each other, arrows going opposite directions. But positive coefficient, that's what we see. Here's just going to be reversed with an odd degree with a negative coefficient. Here they're both down. Here they're down up. Yeah. And then as you write the notation, You're going to say as x approaches negative infinity, as x approaches negative infinity. I know it's very cumbersome to do, but I am going to force you to do it because you have to get in the habit of notational fluency. It's kind of a big deal in math, especially when we're moving to the second semester of Algebra 2. Want to make sure you can understand all the notations we're doing. And then here you're going to say as x approaches positive infinity, 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 as x approaches positive infinity. Okay. So what is y doing in each of these cases here? And what is y doing in each of these cases here? So let's focus on the left side. So we already know what's happening on the left side based upon the degree and leading coefficient. We had an even degree with an odd, with a positive, so that's even and positive, odd, positive. Degrees you care about even or odd. Leading coefficients you care about positive or negative. Obviously it's odd and negative, even and negative, odd and positive. So, but we already see what's happening with the arrows. We already know. So for the first and 3x to 4, it's positive infinity. But on the right side, it's also going to be positive infinity. On the left side here, it's going to be negative infinity and positive infinity. Remember, it's down, up. Here, it's reversed. Positive infinity, negative infinity. Here, they're both down. Negative infinity, oops, negative infinity. And here's going to be negative infinity, positive infinity. The last case was pretty much the same thing as the second case here, with an odd degree at the positive coefficient, leading coefficient. Now you can actually try graphing these if you could, and do a little factoring as well. So here I expect my arrows to look like this. Here I expect my arrows to look like this. Y-intercept is just a constant, which is -1. Here the y-intercept is just 4. Remember, we plug in 0 for x for y-intercepts, but the constant is just going to be your y-intercept anyway. X-intercept, you have to do a little factoring. Factor by grouping, remember that? So in this case, I should get negative x squared coming out, x minus 1 plus 1 times x minus 1. We get negative x squared plus 1, x minus 1. Here, factor out x cubed. And that's x minus 1. Here you can factor out a -4, I think. Oh, never mind. You can't find the x-intercept for this one. Thought we could for... Never mind. We can't. Because these are not going to be identical. So, actually, let's get rid of that 2 there so we can do it. So now I could do it. So you get x cubed minus 4 and x minus 1. So if I were to graph these, kind of know what to expect with end behavior. Now, for now, you can use a calculator. It's totally fine, but I want to make sure you're comfortable with, the construction of it. So the end behavior we consider. The y-intercept, of course, is -1 here. The y-intercept was 4 here. And looks like our x-intercept is going to be plus or minus 1 here. Here it looks like it's going to be the cube root of 4 and 1. So it's going to kind of look like this. It's going to be something kind of funky like that. But here, probably going to do something kind of like this. We'll get into more details about this later in the chapter. 5 is when it all comes together. And then here you could just graph these again. Again, if you use a graphing calculator, that's totally fine. So if I do negative x cubed plus x squared plus x minus 1. Yeah, you're going to get something kind of like this. Actually, we just did that one. So, and then we get rid of the square symbol here. Okay, so that was repetitive. Okay. That's okay. X to the 4 minus x cubed minus 4x plus 4. Yeah, we did get something kind of funky like this. But it's always good to understand the end behavior so that your graph makes sense. And of course, how to factor and finding y-intercepts is just a constant. All good stuff. All stuff that's helpful to make sure you're successful with this. And actually, let me redo this one. It's supposed to be crossing at 4. But look at something kind of like that. All right, so that concludes the video on 5.2.